Welcome everybody, good to see you all here. So here we are at Pre-Calc 11 and we're looking at the video that supports this booklet here, Applications of Soh Cah Toa. So we'll start off with doing some word problems, then we'll look at multiple triangles, and then we'll think a little bit about area and how to deal with those. And it shouldn't be too bad. It's just an extension of the work that we did last class. Only now we're dealing with, new types of contexts with how we manage our work. So let's have a look at our first detail, thinking about a word problem. Alright, here's a classic example. And this is the kind of stuff that you'd see anywhere in any kind of textbook or anything like that. And so we have a few of these where you're having to solve for like the height of a building. So you could measure the shadow of a building, and then you might be able to take like a protractor or what they call a sextant, and you can measure the angle of the sun's rays, which we will call the angle of elevation off the ground, and you could find that value. And they'd ask you to tell you the height of the building. Now you can do this with mountains and trees and all sorts of things. In fact, this is the same sort of thing that they use to measure distance from planets. It's a little more complicated than that, but it's kind of the same idea. So let me just put down some numbers and we'll see if we can make some calculations. Okay, so let's say you take out your measuring tape and you measure the shadow at 5 meters long, or whatever, and you take your compass and your protractor and you measure the angle of the sun's rays, or the angle of elevation, to be 55 degrees. So you can calculate the building. And you could do this at home. Calculate the height of your house, or the height of the big tree out in front of your yard, or at the park, or wherever. Or the height of, flagpole, say. So this is just a standard trick. And okay, so let's get to the calculation. We have to start off with determining whether we're using sine, cosine, or tangent. So that's the angle. That's the shadow that we know, and the height of the building, well, that's the x. So angle, that's the adjacent, and that's the opposite. So opposite, adjacent, well, here, let me help you out a little bit. Right, opposite and adjacent. So sine is opposite hypotenuse, so that's not it. Cosine is adjacent hypotenuse, so that's not it. There you go, tangent, opposite and adjacent. So we start off with that. Now if you're wondering what the heck's going on, you got to make sure that you watch the videos from the previous assignment. That's where we went over the basics of solving for triangles. And so I'm just going to pick up there. If you need to go back, go back. Do what you got to do. Okay, so let's set up the algebra on that. Right, so we're talking about tangent. Tangent of 55 degrees, so that's that. It's equal to opposite over adjacent. So the opposite we said was x, and the adjacent was 5. So x over 5. And there's the algebra setup. And now you got to turn tan 55 into a decimal. Use your calculator for that. Make sure it's in degree mode, not radian mode or anything like that. Degree mode. It's important. Okay, so tangent 55 is 1.43, and that's equal to x over 5. Do I need to flip anything? Nope, x is on the top, so I got easy peasy, just times both sides by 5. Okay, times both sides by 5. The 5 on the bottom cancels out. You got an easy peasy calculation. Okay, so there's my answer, 7.14. 2 stories about. So, okay, let's have a look at a question where we're solving for a missing angle. Okay, so one of the other applications might be where you're having to measure the incline of a road. If you've ever driven up a hill or down a hill, usually very steep ones, they usually have like a little sign saying this is in 11% incline or decline. So what I want to do is I want to go over how to calculate the angle of that inclination or depression. And so it's the same thing. I'd say here's how long the road is, this is how high it rises, so what's the angle of inclination that you have going on? Okay, it's the same process, you just have to solve for a missing angle. So again, we have to ask ourselves, okay, are we starting with sine, cosine, or tangent? Well, from the angle that we're trying to find, this is our opposite, and this is our hypotenuse, right? Because, this comes from the 90-degree angle. So opposite and hypotenuse. So sine is opposite and hypotenuse. There it is right there. We're using sine. So I set it up to look like this. Okay, now I've done something wrong in this picture. Can you see what it is? Pause it if you can't find it and see what you can find out what I did wrong. Okay, I'll tell you. The units are not the same. This is in kilometers and this is in meters. So you're going to have to change them to have the same units. That's easy. 2 kilometers, that's 2,000 meters. And so this should really be 2,000. Okay, no big deal. Right now I've made that change. So I've got to calculate what 400 divided by 2,000 is. And if you do that on your calculator, that comes out to 0. Let's see, 0.2. Okay, so now I've got to do the inverse sine to both sides. Right, cancel out sine. I got to go sine to the -1. I got to go sine to the -1 over here. And those guys cancel. And I get 11.5 degrees. 11.5 degrees. So the first page of your booklet is just going through some very simple word problems like that. You know, seeing the triangle in a like more of a realistic context than what you're just simply calculating at the moment. This here is another common question that you see in this area of study, and they basically get you to use one triangle, this triangle over here. You find the hypotenuse of that triangle, and then you use it as one of the sides to help you find the hypotenuse of the other triangle. So you wind up working with more than one triangle, and this is really illustrates your ability to see what you can and can't determine. Right? Can you find a common side? Right? Are you able to visualize that? You know that you can do it. You know, do you have enough information to do it? Well, we have a side and we have an angle. So when we have a side and an angle, we can find any side of a triangle. So we have to find side AB first, and then we use that to find side AD. Okay, so let's go through the process for this question. Right, so to find AB, right, I use the first triangle here. I know the angle. I have to know that that's the adjacent, and I need to know the hypotenuse. So, right, Soh Cah Toa. Right, so adjacent and hypotenuse, that means cosine, cosine is adjacent over hypotenuse, so that's why I'm using cosine down here. There's the adjacent, 14, and there's the hypotenuse. We won't call it x, maybe we'll call it some other variable just to keep them separate. Okay, equals y, and so I got to be able to calculate that. Alright, so let's see if you can do it. Okay, so cos 30 is 0.866 is equal to 14 over y times both sides by 14, right? No. You don't times by 14. Divide by 14? I don't know. I don't know. It's okay, don't worry. Remember, if the y is on the bottom, you can do a little swappy dance over here. You can, or you can do it like this if you like. You can flip both fractions, however you like. Let's go through that. So 1 over 0.866 is equal to y over 14. Right, like that. Now I can times both sides by 14. Right, that cancels, so I'm left with 14 divided by 0.866. Or, in other words, right, what you can do is this. See, this is 0.866 is equal to 14 over y. When you have a situation like this, you can swap these two. And so I get y, right, y over here is equal to 14 over 0.866, right? So that's that. And I can calculate that. So 14 divided by 0.866 is 16.1. But that's not our final answer, right? This is 16.1. And I got to use that value again in the next triangle, right triangle ABD, and I got to use that to calculate x. So let's go forward and do that. Okay, so from angle 40, or 40 degrees up here, this side is now the adjacent of the second triangle. That's the adjacent, that's the hypotenuse. So adjacent and hypotenuse still cosine. Right, so cos 40 is adjacent, 16.1 divided by x. See if you can solve that. Same trick as before. Right, when x is on the bottom and you only have one number over there, you just do the little swappy dance, right? The x goes up over here and the 0.76 goes down below. You're just basically swapping those positions. We just talked about it in like 10-15 seconds ago. So you can scroll back if you like. And so here's the calculation you need to make. Okay, and so I get 21.0. And that is the value of AD. So you have to look and see what pieces of information can you find. Is it useful to find? Like we could find CB over here. That's the same problem. We use tangent, I guess. But that doesn't help us anything. Right? So what? Right? And we have to look to see if there's any sides that are like duplicated from one triangle to the other. And so in part of your work in your booklet, you're going to see this situation where you have to use both parts. Now here's another one where you have to draw the line yourself, and that's a little tricky too. Okay, so you'll see a question like this, and you'll notice that this isn't a 90-degree angle, right? 50 and 35 is 85, so if you do like the triangle is 180 degrees, then you know that's going to be 95, and we don't have a right angle. So that's a problem because we can't use our Soh Cah Toa yet until we establish a right angle. So that's no problem. We can create one ourselves, right? You take your pen, put it on the paper, and you draw a 90-degree extra line right down the middle. Boom, like that, right? And so now I can calculate, we call this point D, I can calculate CD from this side over here, and then use that value that I get, and I calculate it to use the same angle to find side value x. So let's go through the calculations. I'll write it all out and I'll explain each part. Okay, so my first job, right, is to find the middle line that I drew in for myself, and you'll have to do that on some of the questions. No big deal, right? Just know that you can do that. You're allowed to make marks on your paper if you need to. Now, we have other ways to deal with questions like this, which we'll see in the next lesson and the next assignment, but for right now, this is how we do it. So, okay, that's the angle, that's the opposite, that's the hypotenuse. Opposite and hypotenuse is sine, right? Sine is opposite over hypotenuse. So that's the sine 50. Opposite is y. Hypotenuse is 10. Calculate it, you get 7.66. So that's this value here, y, right? That's its value. And then you can use that in the other triangle, right? Triangle CDB. And you'd say, okay, well, sine 35, right, because this is opposite and that's hypotenuse, is equal to the opposite y, which we just calculated, right? 7.66 divided by x, which is what this is right here. You plug in the numbers, right? 7.66 is that number there. I did a little swappy dance. I move those across from each other. There's the x, there's the sine 35. Plug in the numbers, and I get the value, 13.2. So you'll have to just, use some creativity and see how the questions play out. I didn't make them too hard, but it's, challenging enough for you to, require you to be creative about how you use the skills that you've already learned. And that's why it's important that you learn the skills along each step of the way, because when you get to the times where you need to be creative, if you've been kind of, copying or, getting your Uncle Mike to do it for you or whatever, then this is going to wind up being overwhelming. So make sure you learn each skill along the way so that when you get to these more complex ideas, you're dealing with that. Now the last thing that I want to talk a little bit about is something called calculating area. Alright, and here's how we manage that. Alright, so if you're asked to calculate the area, and I'm using the same triangle as the last example, if I ask you to calculate the area of this triangle, well, area is base times height divided by 2. Well, the height, that's your 90-degree bar that you've got going on. And, okay, so area is base times height, so you got to calculate the base, right? We already have the height, right? 7.6, that's from the last example. So that's the height. And now the base, well, you got to calculate both parts. That's this part plus that part. So this is the math for the first part, a to d, right? Because cosine, right? Adjacent hypotenuse, 50 degrees, blah, 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 down here. And the other one, d to b, right? So tangent, because we have opposite and adjacent, so that's tangent. That's this, and so there's the calculation. So to add them up, that would get you the base. Right, so there's the base, there's the height. Our formula, right, is base times height divided by 2. So we just plug in those numbers and calculate the area. Okay, so base, 17.37, that's that number there. Height, 7.66, right, that's the one that we calculated from the last example that we did a couple minutes back. So those are our two numbers. Divide by 2, because that's our formula, right, and there's your answer. And so you got the last couple questions on the in the booklet that ask you to deal with those things. So that's it, folks. That's the next step in our trigonometry understanding. And next assignment, we'll be looking at something called the sine and the cosine laws, which gets us to do this kind of stuff a lot quicker. So we kind of have to do it the slow way to appreciate the new way that's coming. Alright guys, take care. Glad to see you. I hope everybody's safe.